9.4, solving quadratic equations by completing the square. Okay, so our first two types of problems, these are some review problems from the last couple of sections. I can solve equations like this using a square root. So if I want to undo the square here, I can take the square root, but I have to do the square root of both sides of the equation. So when I take the square root of x squared, that's just x. But when I take the square root of 81, it's not just going to be 9 because there's a positive and a negative square root of 81. So that's really important because 9 times 9 is 81, but also negative 9 times negative 9 is 81. So that means my solutions here are positive and negative 9. Really important to remember every time you take the square root of both sides of an equation, you got a positive and a negative root. Okay, so the same kind of thing here. If I want to get rid of this exponent, I can take the square root of both sides. The left side will just be x minus 2. The right side will be plus or minus root 81. And the square root of 81 is 9. So I've got x minus 2 equals plus or minus 9. Okay. Now I want to solve this for x, so I'm going to add 2 to both sides, and you could say plus or minus 9 plus 2, but I'm going to put the 2 in front of the plus minus 9, okay? So now I can actually simplify this further because I could say, all right, I've got x equals 2 plus 9, or I've got x equals 2 minus 9. And I can simplify both of those because they're like terms. So that means x will equal 11 from this path, and x would equal negative 7 from this path. Okay? All right, and then factoring some trinomials. So I've got a trinomial here, and assuming this is factorable, which it is, it's going to factor into this form. It has to be x's in front to get the x squared when we FOIL. I'm going to set up a diamond problem. There's lots of different ways you can do this. But you're going to take the b, which is the coefficient of the x term, and put that on top. And then the c is the constant at the end, the number without an x. That goes on bottom. Now I'm looking for two numbers that add to 10. Same two numbers multiply to 24. Okay, so I'm going through this kind of quickly because I've done this a lot in the previous sections. So I'm thinking of different ways to multiply to get 24. 1 and 24, but those don't add to 10. 2 and 12, those would add to 14. 4 and 6, right? 4 and 6 multiply to 24, and they also add to 10. So 4 and 6 are the solutions to my diamond problem, and that tells me what goes in the back of these parentheses. So that's a 4 and a 6, and then I just separate them from the x's. And you could have these two factors in reverse order. So you could have x plus 6 times x plus 4, and that's the same thing. Okay? All right, let's try another here. So this is oh, by the way, I should always look when I'm factoring for a common factor. There isn't one here. There's nothing that goes into all three terms. There isn't here either. So then my next step would be to go to a diamond problem, just like on the last problem. So here I put a negative 4 on top and a negative 21 on bottom. And then I'm brainstorming ways to multiply to get negative 21. So I could do those two or these. Those are actually different pairs because they add up to different things, but neither of them add up to negative 4. How about a 3 and negative 7, or negative 3 and positive 7? And that's the only pair there that is going to add up to negative 4. So then that tells me I have a negative 3 and a positive 7. So again, you could have those factors in either order, but the 3 has to be negative and the 7 has to be positive. You can't switch the signs. Okay? All right. So let's talk about a perfect square trinomial. So a perfect square trinomial is a trinomial that factors into something times itself. So if I were to set up a diamond problem here like I did on the previous examples, I would end up with x plus 2 times x plus 2, which I could write as x plus 2 squared, the quantity x plus 2 squared. So that's a perfect square trinomial, okay? So on these examples down below, what we're going to be doing is looking for a term that goes in these boxes so that I can create a perfect square trinomial, all right? And there's a little formula you can use, which is written right here. So if we've got something in this format, x squared plus bx plus c, then c is going to equal b over 2 squared, okay? So since these both begin with x squared, I can say, okay, c is going to equal b over 2 squared. The b is going to be the coefficient of the x term. So in this case, it's going to be 10 over 2 squared. So I'm going to do the division first. 10 divided by 2 is 5, and 5 squared is 25. So that means 25 is, I call it the mystery number sometimes, but that's the number that's going to create a perfect square trinomial. Okay, so we found that missing term, and then the second part of the directions say, then factor the trinomial. Okay, so now I'm going to take this and factor it, and it should factor into something times itself. So let's go ahead and try it out. I'm going to set up a diamond problem here. I'm looking for two numbers that multiply to 25, the same two numbers add to 10, and that's going to be double fives. So that means when we factor this, it's going to be x plus 5 times x plus 5. You could write it like that. If we're completing the square, which is what we're working towards, we're going to want to write it as a binomial squared. So I'm going to write it like that, but this would be acceptable too. Okay. All right, let's try another here. So I'm seeing, okay, b here is -4. So then that means my mystery number, the c, is going to be b over 2 squared. So b is -4. I'm going to divide that by 2 and square it. So -4 divided by 2 is -2. And then when I square -2, that's +4. Okay. Got my mystery number. And now let's try factoring this. So here, I'll do my little diamond problem up here. Should be something. I should get the same number on both sides if I want this to factor into something times itself. Something, okay, 1 and 4, that's no good. 2 and 2, I can add those to 4, but I can't add them to -4. But if I use -2's, -2 times -2 is +4. But when you add them together, you get a -4. So then this will factor to x minus 2 times itself, also known as the quantity x minus 2 squared. Let's try two more on the next page. These ones are going to be a little trickier. At first glance, they look like they'd be about the same. It's not like we have really big numbers or anything, but these are a little tougher just because those b values are odd. Okay, so that means when you divide them in two, you're going to get a fraction. Okay, so b is 7 here. And so then I'm going to do, for this part, it's going to be b over 2 squared. So here that's 7 over 2 squared. Okay, so you could write that as 3.5 and then square that and get a decimal. I'm just going to stick with a fraction here. So I'm thinking 7 over 2 times 7 over 2. Well, you can just square the top and the bottom. If you multiply it 7 over 2 times 7 over 2, go straight across. You get a 49 on top, and then 2 times 2 on bottom would give you a 4. So this is going to be 49/4. I don't usually like to write fractions like that, but just to make it fit in there. Okay, so there's my perfect square trinomial. Now, when I factor this, it's going to be a little tricky, okay? Now, I know it's going to be something times itself, right? I know it's going to be in that format if I got the right mystery number, okay? So let's set up a diamond problem here. 7 is the b term, and 49/4 is the c term. So I'm looking for two things that add to 7 and multiply to 49/4. So it's a little weird to think, well, what multiplies to 49/4? Well, the good news is we just multiplied something to get 49/4 when we found the mystery number down here, right? We did 7 over 2 times 7 over 2. So this is going to give you the solution to the diamond problem. So 7 over 2 times 7 over 2 would give you 49/4. But if you add these together, they're each 3.5, right? So 3.5 plus 3.5 would be 7. So that means this is what my squared, my factored perfect square trinomial is going to look like. Okay. All right. So keep in mind this b is negative. So the negative is part of the b. b is -5. So I'm going to do b over 2 squared. That means -5 over 2 squared. Okay, and a negative times a negative, -5/2 times -5/2, that'll come out positive. So -5 times -5 would be 25, and then 2 times 2 would be 4. Okay, so 25/4 is the mystery number. Okay, So now when I'm factoring it, it should factor into something times itself, because it should be a perfect square trinomial, okay? And then again, I'll set up a diamond problem. Here, I'll use this little space. -5 is the b, and that fraction, 25/4, is the c. Okay, again, multiplying to get 25/4 is kind of weird, but we just did that. Now we used -5/2 times -5/2, so I'm going to do that, even though +5/2 times itself would also equal 25/4. But if these were both positive, when you add them together, you get a positive number up here, not a negative one. Okay, so since I had a negative number there, I'm going to stick with that. And then this is what that would look like factored. Okay. All right, so all of that background info brings us to actually completing the square. Okay, so we're going to solve some equations by completing the square. And first thing you're going to do, this is when your x squared coefficient is 1, okay? So it's going to get a little trickier if you've got 2 or 3 or 4 or something like that in front of the x squared. But the first thing you'll want to do is write your trinomial in this kind of a format. So the d here is just going to be the coefficient, the constant. So you see how the 3 is on the right side and the -8. I want it in this format where the x squared term and the x term are on the left. So that first step is already done on these two examples. Okay. Next thing I'm going to do is create a perfect square trinomial on the left side of the equation. Okay. So I'm going to add something to the left side of the equation so that this is a perfect square trinomial. Now I can add whatever I want to the left side of the equation as long as I add the same thing to the right side of the equation. Okay? All right. And then the way I'm going to find this number is using that little formula. So this is going to be the c value, right? So I'm going to use b over 2 squared. Now the b here is -2. Okay, and then I'll do the division. So this is -1 squared, and that comes out to +1. So that means my mystery number here is 1. And since I added 1 to the left side of the equation, I want to add 1 to the right side of the equation as well to balance it out. Okay, now on the left side, next thing to do is to factor this. I'm going to factor this. It should factor into something times itself. Okay, so let's set up a little diamond problem here. Looking for two numbers that add to -2 and multiply to 1. Okay, and I know it's going to factor into something times itself like that. All right, so let's see. There's really only two options multiplying to get 1 using integers. 1 times 1, well, that doesn't add to -2. Or -1 times -1, and that one does work. So that would factor into x minus 1 times itself. Okay. On the right side, I'm just going to do the addition here. 3 plus 1 is 4. Okay. So now that I've got this left side factored like this into something squared, now I can take the square root of both sides of the equation. That's the idea. I want to mess with the equation so that I've got a perfect square trinomial, which means it's going to be something squared. Then I can use square roots. Okay? So when I take the square root of both sides of the equation, the left side's just going to be x minus 1. Don't forget you got a positive and negative root of 4 on the other side though. Okay? So I've got plus or minus 2 then, because the square root of 4 is 2. All right? Now I'm going to solve this for x. So I'm going to add 1 to both sides. I like to put the 1 in front of the plus minus. Okay? And then I actually want to go down both of these paths. So I've got 1 plus 2, and x could also equal 1 minus 2. So I'm going to get two solutions here. Okay? So x is going to equal 3, or x is going to equal -1. Okay? All right, let's try another round. Just separate that there. Okay. So I can see the x squared and the x term are already on the left and the other terms on the right. So next up, we're going to look for the mystery number. Okay, so that's going to be something, well, that something is going to be b over 2 squared. The b here is 12, so 12 over 2 squared. 12 divided by 2 is 6, and then 6 squared is 36. So that means my mystery number here is 36. Okay, on the left side, I want to factor this. So So let's see, 12 and 36. Looking for two numbers that add to 12 and multiply to 6. They should be the same numbers. So hopefully pretty quickly you'd arrive at double sixes, right? So that means this is going to factor into x plus 6 times x plus 6, or just the quantity x plus 6 squared. Okay. On the right side, I'm going to do the addition here. So I'm thinking negative 8 plus 36. So you could think of that as 36 minus 8 would be the same thing. And it's going to be 28. Okay. All right, now let's take the square root of both sides. Don't forget the plus minus symbol, okay? Now I want to get the x isolated. I don't really want to know what x plus 6 equals. I want to know what x equals. So I'm going to subtract 6 from both sides. I'm going to put the negative 6 in front of the plus minus. That's usually the way that's done, okay? Now, you could leave it like this. You could also put root 28 into a calculator to get a decimal. But we're going to use usually simple radical form here, okay? So that means I'm going to break this apart looking for twins. So we talked about that in a previous section, but I'll review it quickly. So I'm trying to think of a multiplication problem where the answer is 28. I don't want to use 1 times 28, but I could use 2 times 14, or I could use 4 times 7, something like that. Okay, so that would be equivalent. And now I'm looking for twins down here. I don't have twins. I don't have the same number twice, but I could still break up the 4 into 2 times 2. Okay, so there, 2 times 2 times 7 is 28, right? But now I've got these twins, and if this is a jail, if you have twins, you can make a jailbreak. So one of the twins is going to distract the guards and gets shot and dies, but the other twin gets out. Okay, so from that group of 2's, one of them is going to get out, and the one that gets out is going to move right out there, right outside of the jail, not in front of the plus minus. And then the 7, since it doesn't have a twin, is stuck in there, and then this is simple radical form. Okay, and we can't combine these any further because they're not like terms. One of them has a radical and one of them, the terms, doesn't. Okay, so that's as far as we can simplify that without just doing a decimal approximation. On the next page, got some more examples, but these are a little trickier. There's another layer to it because if you look at these problems, the a value, the x squared coefficient, is not 1. It's something other than 1. So there's an extra step. There's just one extra step, and that step is to get it to say 1. So instead of a 3, I want this to say 1x squared. So what I'm going to do is take the whole equation and divide everything by whatever a is. So in this case, I'm going to divide everything by 3, because if I divide this piece by 3, then it will say x squared. And I can do that as long as I divide the entire equation by 3. Okay, so that gives me x squared, and luckily 3 goes in evenly to all 3 of these terms, because if it doesn't, then you just have fractions or decimals, and it would be kind of a mess, but you could still use completing the square. Okay, and then from there on out, it's going to be the same as the previous problem. So next I'm going to look for a mystery number to get a perfect square trinomial, and whatever that mystery number is, I'm going to have to add it to both sides. Okay, and then let's see here, this mystery number, I'll do that right here, b over 2 squared. So b here is negative 8. Negative 8 divided by 2 is negative 4. Then when I square, I get 16. So 16 is my mystery number. Okay, and then I'm going to factor this. So I have negative 8 on top and 16 on bottom. Looking for two numbers. They should be the same two numbers to multiply to get 16 and add to get negative 8. And they would be negative 4s, double negative 4s. So this is x minus 4 times x minus 4, also known as x minus 4 squared. Okay, and then negative 9 plus 16, that's the same as 16 minus 9. That's going to be 7. Okay, next up, I'm going to square both sides. And don't forget, not square, take the square root of both sides. Don't forget to put in the plus minus symbol there on the right. Okay, and next I want to add 4 to both sides. I'm going to put the 4 in front of the plus minus, and then I'm going to try to put this in simple radical form, but it actually is in simple radical form because you can't break up the 7, and there's no twins there. So I'm going to leave that as x equals 4 plus or minus the square root of 7. Okay. Same kind of deal here. I want to get rid of the 100, and I can do that by dividing by 100. That just means I have to divide everything by 100, including the 0, even though 0 divided by 100 is just 0. So this is nice here because 100 goes into everything evenly. 2 of the zeros would cancel there, so that's going to be negative 10. And that's all equal to 0. Okay. Now this one has this coefficient, this constant, sorry, on the left side of the equation, but that's where the mystery number would go, which is not going to be negative 10. So I want to move that 10 to the other side, like that. I'm going to add 10 to both sides. Now I'm going to look for the mystery number. Okay, and have to add it to both sides. Okay, so this mystery number then, I'll do that up here. B over 2 squared. B here, I want to use this B. So B is going to be 4, not 400. I want to use the B after I did the dividing. Okay, so 4 over 2 squared. That's 2 squared, which is 4. So my mystery number is 4. Okay, and then I'll factor over here. Let me just separate that. So I'm going to set up a diamond problem. Need the same two numbers to multiply to get 4 and also to add to get 4. That would be double 2's. So then this is going to factor into x plus 2 times itself, or x plus 2 squared. On the right side, 10 plus 4 is 14. Okay. And now to solve for x, I can take the square root of both sides. So x plus 2 would equal plus or minus the square root of 14. And I'm going to move the 2 to isolate the x. So subtract 2 from both sides, and I'm putting that negative 2 in front of the plus minus symbol. Okay, and you still want to look for twins there, but you can only break that up into 2 times 7, so there are no twins there. That's in simple radical form. Okay, all right. Let's talk about finding minimum and maximum values. So the minimum or maximum value, say of a parabola, the minimum is going to be the y-coordinate of the vertex. We're talking about parabolas here because we're talking about quadratic equations. Okay, so the y-coordinate, because that's the coordinate that has to do with the height. And when we're talking about minimum and maximum, we're really talking about minimum and maximum height of a parabola. So if a parabola opens upwards, like, say this is a parabola, then it would be the y-coordinate of the bottom, right? This is going to be the minimum because it's the lowest point. But if it opens down, then it's the y-coordinate of the top, and that's your maximum, okay? So if A is positive, then the parabola is going to open up, and it has a minimum value like I was just talking about, right? Because it would look something like that, and that would be the bottom of the parabola. If A is negative, then you're going to get a parabola that opens downwards, and that means it's going to have a maximum. It's going to have a highest step point, okay? So what we want to do is we're going to write, to find a minimum or maximum like we're going to do on these problems here, we're going to write our equation in vertex form, okay? And there's actually 2 ways to do this. One way to do this would be to use the axis of symmetry formula to find the x-coordinate of the vertex, and then you can find the y-coordinate from that. And then you can figure out what the minimum or maximum is. The other way to do it is by completing the square. So since that's what this section is about, I'm going to use that method. Okay, so we're going to take these equations. They're in standard form right now, but we're going to put them in vertex form so that we can tell what the vertex is. And we can do that by completing the square, okay? So it's similar to the process we've already been using. So I'm going to try to make a perfect square trinomial on the right side. So I want to move the 40 over. So I'm going to subtract 40 from both sides so that I just have the x terms on the right side, okay? And now I'm going to be looking for my mystery number so that I get a perfect square trinomial. So since I'm going to be adding that something to this side, I'm going to have to add it to the other side as well. Okay, and I'm still going to use b over 2 squared here. So b over 2 squared is going to give me this number. My b is 12. And 12 over 2 is 6. 6 squared is 36. So this number is 36. Okay. On the right side, I'm going to factor this just like I did on the other problems. And since it's a perfect square trinomial, I should get something times itself. So let's see. A 12 on top and a 36 on bottom. And this is going to work with double sixes, right? So this should be x plus 6 times x plus 6. On the left side, I'm just going to do the arithmetic, so I'm going to combine negative 40 and 36. They would combine to negative 4, so I've got y minus 4. Okay? And this is starting to look a lot like vertex form. It's not quite there because in vertex form, the y is isolated. Well, all we have to do to isolate the y is add 4 to both sides. So I'm going to add 4 to the end there, and hey, now it's in vertex form. So it said write the equation in vertex form. Well, I did that, right? So now on the second part, it says find the minimum or maximum. So the key is knowing what the vertex is. But if you know how to use vertex form, you just take the part inside the parentheses and set it equal to 0. Okay, and if you solve this, x equals negative 6, that is going to be the x coordinate of your vertex. And then this number, whatever it is going to be the y coordinate. So that's my vertex. Then I just need to think, does this parabola open up or down? Okay, so thinking about this one, the a value would be right here. The a value is 1. So this one's going to open upwards. So it might look something like this. Okay, so I know I'm interested in the y coordinate, which is 4, and now I can see that's going to be the lowest point on this parabola since this opens up. So now I can say the minimum is going to be 4. Okay, if the parabola opened downwards, then it would have a maximum. Okay, but all the rest of the work would be pretty much the same. Okay, speaking of parabolas open downwards, I know this one's going to, right, because the a is negative. So let's try this one out. Same kind of process. So I want to move the 2 over to the other side. So I've got y minus 2 equals negative x squared plus 2x. Okay. Now, I actually want to do, well, you don't have to, but I like to have the x squared be positive. So the way I'm going to do this on this problem is I'm going to factor a negative out on the right side of the equation. Okay, so I'm going to do this. I'm thinking negative 1 times x squared would be negative x squared. Negative 1 times something would be 2x. That would be negative 2x. Okay, and now I'm going to look for the mystery number. Okay, so I'm going to do this. Okay, and now there's a little piece that gets missed. It's easy to just think, oh, I'll just add the box to the left side as well. But you got to remember that this has a negative factored out of it. So if I really want to add the same thing to both sides of the equation, I want to add the opposite of the mystery number because this had a negative factored out. Now that's the opposite of the mystery number as well. So then this would balance out with that. Okay? Little tricky there. All right. So now let's find the mystery number. So I'm going to do b over 2 squared. The b here is negative 2. Okay, and that's negative 1 squared, which is positive 1. So that should go in both those boxes. Okay. On the left side, I'm going to combine negative 2 and negative 1 to negative 3. On the right side, I'm going to factor this. Okay, so let's see. I'll do a little diamond problem here. So it's going to be negative 1s, right? Negative 1 times negative 1 is positive 1. When you add them together, it's negative 2. So then the parentheses is going to factor to x minus 1 times x minus 1, or the quantity x minus 1 squared. And now I'm going to move the 3 back over to finish putting it in vertex form. Okay. So now this one, I'm kind of running out of space. I know it's opening downwards because I got that negative. And the vertex, if you set this equal to 0, the x-coordinate would be 1, the y-coordinate would be 3. And now I can see, hey, that's the maximum. I'm looking at the y-coordinate. This one is going to be the maximum, and it's going to equal 3. Okay. Okay, so these problems are a little tricky when we're putting these in vertex form when you have a number in front of the x squared, like we had a -1 in front of the x squared. Okay, so let me show you a couple more where we've got a number in front of the x squared. Now on these problems, a lot of times I'll see people divide the whole equation by 2. And you don't really want to do that. That worked great if we just have 0 there instead of y. But it's not going to work great with the y because then we'd have y over 2. And I don't want to deal with y over 2 or 1/2 y. And that's what I'd have to do if I divided everything by 2. Okay? So what I want to do instead, I'm going to move the 10 first, because I'm going to be looking for a mystery number. But before I look for that mystery number on the right, I've got to factor out the 2. Okay? So then I'm thinking 2 times something is x squared, that's x squared. 2 times something is 12x, that's 6x. Okay? And so now I've got this. All right? So now I'm going to be looking for the mystery number on the right side, but I got to remember that a 2 is factored out of this whole trinomial. Okay? So I got to account for that on the other side of the equation. So instead of just adding in the mystery number, I'm going to add 2 times the mystery number because this mystery number has a 2 factored out of it. So I want a 2 factored out of my mystery number on the other side as well. And now this is going to be equivalent to that. Okay? It's a little tricky. It's easy to forget that step. Okay? All right. And then, so let's find our mystery number here. We're going to do b over 2 squared. B here is 6. I want to use this b, not 12, not the original b, but the b from the trinomial that begins with x squared. So I've got 6 over 2 squared. That's 3 squared, which is 9. Okay. Now I'm going to factor this trinomial. Should factor into something times itself. And I can do this with double 3's. 3 times 3 is 9. 3 plus 3 is 6. So this is going to be 2. Still got the 2 out there. And then I've got x plus 3 times x plus 3, or x plus 3 squared. Okay. On the left side, I'm thinking, okay, -10 plus 18. 2 times 9 is 18. And then let's combine -10 and 18. They add up to 8. Okay, and now I just moved the 8, so I'm going to subtract 8 from both sides of the equation here. And I've got my equation in vertex form, so that's the first part. So now I'm thinking, which way does this parabola open? Does it open up or down? Well, this is a positive number, right? My a value in either form of the equation is positive. So this one's going to open up. So I'm not going to spend a bunch of time graphing it, but it would look something like that. The x-coordinate, I'd set this equal to 0, which means x would equal -3. And then this is going to be the y. Y equals 8. So -3, -8 would be the vertex. And then for a minimum or maximum, we're looking for the y-coordinate. So I know that's going to be the 8. And this is going to be the minimum because it's at the bottom of that parabola. So any parabola that opens upwards is going to have a minimum. Any one that opens downwards is going to have a maximum. Okay. All right, let's try one more. A lot in this section. All right, so let's move this 30 over first. I'm going to add 30 to both sides. Okay, now I want to look for a mystery number, but before I do that, I want to factor out a -3. Okay, -3 times something is -3x squared. -3 times something is 24x. That would be -8x. Now I'm going to be looking for the mystery number. Okay, So when I do that, I don't know why I left so much space there. I've got negative 3 and then x squared minus 8x plus something. Okay, on the other side, I've got y plus 30 plus negative 3 times something. That negative 3 is the part that gets forgotten often. Now, I didn't need that plus sign because I'm adding a negative, but that's okay. I already wrote it in. Okay. All right, let's find our mystery number, b over 2 squared. The b here is negative 8. So I've got negative 4 squared, which would be positive 16. Notice the mystery number is always positive, and that's because you're always squaring something to get it. So it's always going to come out positive. Okay, then let's factor this trinomial over here. So I'm looking for two numbers that add to negative 8, multiply to 16. It should be the same number. 4 times 4 is 16, but 4 plus 4 is positive 8. But I can do this with negative 4s, right? So then this factors into x minus 4 times itself, or x minus 4 squared. Okay. On the right, let's see, negative 3 times 16, that would be negative 48. Okay, and then I'll combine these two into negative 18. Okay, so phase 1 is complete. Oh, it's not complete yet. I need to move the 18 over. I was getting ahead of myself there. So let's move the 18 there. Now this is in vertex form. Okay, so then this one is going to open downwards because that a is negative. And I'll use this to get the x coordinate. So x equals 4, and then this would be the y coordinate. So 4, 18 is the vertex. And then the y coordinate is going to be either the maximum or minimum. This one's going to be the maximum because it's at the very top of this parabola that opens down. So the maximum is 18. Okay, that's the end of that very long section, and I'll see you next time.